Alright, let's have a look at problem 416 again. Partition equal subset sum. So in the previous video, we shared a solution using the set and check method. So here we are going to share a method using dynamic programming after we interpret this problem as a 0-1 knapsack problem. So here I will first read through the statement of the problem, and then look at the example and explain the method and idea. And finally we share the code and do the test case check. So let's look at the statement of the problem. So given a non-empty array called nums containing only positive integers, so we are required to find if the array can be partitioned into two subsets such that the sum of the elements in both subsets is equal. So that's the statement of the problem. So here I should mention that the subset or subsets here is or are different from the set concept in mathematics. So here the subsets might be better understood as parts or subsequence. So as we can infer from example 1. So in example 1, the nums is 1, 5, 11, and 5. So if we compute its sum is 22. So the array can be partitioned into 1, 5, 5, and 11. So both of the two subsequences have sum 11. So in the first part we have 1, 5, 5. So repetition appear. So in other words, this is not a set in a strict sense, but it's a subsequence of the original array. So this is example 1. So in example 2, so the sum is an odd number, so we cannot make this partition, so we return false. So this problem, as we mentioned in the previous video, is to be compared with problem 494, the target sum. But in that problem, the return is the number of ways to make the potential sum, and here the return is a boolean. So want to see if we can make such partition or not. So with that said, let's examine the method. So the method we're going to use is the standard dynamic programming for the 0-1 knapsack problem. So here in this problem, so we can first compute the sum of nums array and then divide the sum by 2. So if the sum is an even number, so it's possible that we partition the nums into two subsequences such that each subsequence adds up together to get half of the total sum. So if the sum is an odd number, so it's impossible. So that's basically a first case, edge case. So the idea is that, so once we get the partial sum, so our goal is to pick part or full elements in the nums array such that their sum is that half sum. So this is nothing but the standard 0-1 knapsack problem. So the traditional method to solve 0-1 knapsack problem is dynamic programming. So here the procedure is as follows. So we can compute the sum of the nums and do integer division by 2. Then we are going to define dpij in the 2D table as if we could make a sum g using the first I items in nums. So here I is greater or equal than 0 and less or equal than length nums minus 1. And g is greater or equal than 0, less or equal than the half sum. So that's the range about these indices. So the update rule actually is very intuitive, so we shall explain it in the coding session. So before we do the code, so it's good to check the set and check method for this problem. listed here, and also check the videos for Leetcode 494 for the target sum problem. So now let's look at the code here for this dynamic programming solution. So as a first step, I want to make some preparation and do some edge cases check. So basically, I want to do an integer division. So div mode for the sum of nums and divide by 2. So in other words, I want to check if the sum is an even number. So if r is not equal to 0, it means the sum is not a even number, so we cannot make the partition. So we are going to return false. So otherwise, I'm going to initialize a DP table. So for that, I want to, so the second step is nothing but DP. For that, I'll first track the length information for the nums. And then I'm going to initialize a DP table. So you can use 2D list, or we can use a dictionary. So anyway, the format is not the key, but the idea behind is the key. So here I'm using 0 times. So Q actually is a half sum, so Q plus 1. So for a dummy index range from 0 to length minus 1. So that's the DP table. So notice that in the first column, the first column corresponds if we can make zeros out of this elements in nums, because assumption the nums elements is strictly positive. So the first column in the DP table is always 0. So this is actually set when we initialize the DP table. Then we are going to traverse this DP table and do the update. So that's actually standard for I in range length and for J in range. So I'm going to start from 1. As we just commented, the first column should always be 0. And up to 1 plus Q, right? So first I want to set the first row in the DP table. If I equals 0, so in other words, I want to make to check if we can make a sum J using the first atom in the nums list. So that's actually a thing of check if the first atom in nums equals J or not, right? So then we can do this dp ij, actually I equals 0, equals integer. I want to make it a boolean 0 and 1. So we want to check if nums 0 equals J. If equals J, we can make it. If nums 0 does not equal to J, so it means we cannot make J out of the first element in nums. So this is the first row. Then the other rows. So I'm going to update dpij depending on if we choose the current element nums I or not. So if we do not change, if we do not choose nums I, so we're going to check if we can make the sum J out of the I-1 atoms. So in other words, if dp I-1 J is true or not. And this is the case we do not use current nums J. Or if we use this element nums I, so sorry for the wrong wording. So if we use nums I, so basically we want to check if J is greater or equal than nums I. So if this is the case, and also we want to make sure, so dp I-1 J minus nums I. So this second means that we can use the first I-1 atoms to make the sum J minus nums I. Then adding the current nums I, we are going to make sum J using all the I items, and in this case we use specifically nums I. And again, in the first case, in other words, the part before all, we do not use nums I. And once we've done this update, we're ready to return the result. So we're going to return dp -1, -1. Actually, that's corresponding to length -1 and q. So let's check for a special case, and then do the generic case check. So it passes the first example. So let's do a check for example 2. So yeah, it passes the first one because this one actually was treated as step 1 edge cases. So now let's look at the generic case. Oh yeah, it passes the generic case, and so this solution actually is parallel to the solution for problem 494. So you are encouraged to have a look at the corresponding videos. That's about it for this problem. So thank you very much.